Hi, welcome to question 7 of the Junior Cert Higher Level Maths in 2023. So this question is around coordinate geometry, and we see here that it's a 10 marker. It's a fair chunk of marks, and I like personally coordinate geometry. It's predictable in a way. A, B, C, and D are 4 points in the coordinate plane. It just means in an XY diagram is how we might refer to that. So in A part 1, now I notice here that part 1 and 2 are marked together, so we'll see that on a different page. So the points A and B are shown on the coordinate diagram below, and then it says plot and label the points C, which is 8, 4, and D, which is 3, 6, on the same coordinate diagram. Now the trick here is remember that an XY diagram, it's the X is first, the Y is second. X is first, Y is second. So we have to find for C, where is 8 on the X part? So it's somewhere along this line here. And that combines up with 8, 4, which is here. I'm going to put a big mark on it. I'm going to put C, and I'm going to put 8, 4, because I think they do plot and label. Now then the next one there's D, which is 3 on the X, 6 on the Y. So somewhere along this line here, where it crisscrosses 3 on the X, 6 on the Y, that's D and 3, 6. So that's that. Now, that was part 1. So part 1 and 2 are marked together. So part 2 then says, write the coordinates of the point A and B in the spaces below. The coordinates of the point C and D are already given, and we've just plotted them. So you have to read off what A and B are. So let's do A first. So it's X is always first, then Y. So it's 1 on the X and 1 on the Y. So it's just 1, 1. That's nice. Now B has got a negative part. It's going down below the x-axis. So you can see there it corresponds with -1, but that's on the y, which is the second part. So you remember again, x, y. Then the x value there is corresponding with 6. So that's it. Okay. Now that's part A, 1 and 2. And that's the answer. So part B, which is also 10 marker. Now it's part 1 and 2 marked together. Paulina wants to prove that ABCD is actually a square. Answer B1 and B2 below to show that ABCD is a square. Now they're being very direct here and they're saying show that these bars mean distance. Okay. And the distance of AB, so AB is this line here. Okay. Is that distance the same as this distance? Okay. Now if they are, let's say that this is say 5. Okay. If this is 5 and this is 5, well then this must be 5 and this must be 5. You actually have to prove that, wouldn't you? And if they are, then it's a square. If all sides are equal length, it's a square by definition. So that's probably what part 2 is. Okay, so we need to find the distance of AB. So we clear off this and let's go at it. Now, I probably have the answer done on the next page, but we'll do it like as if we're doing it from scratch. So I'm going to write out the points AB. So A was 1, 1. And not everybody will do this, but to be honest, I'm not naturally inclined to be this labor intensive. But we'll do it simply for the practice in terms of methodology. So the distance between 2 points, you can look up in the maths tables. The formula is, it's in essence, it's Pythagoras' theorem. Okay, the difference in the x's to be squared plus the difference in the y's to be squared. Okay, now excuse my bad writing. Now, what I normally do here is I would label, and I'm going to just change color to a color I can see. Let's go black. So this is okay, I didn't change it. First X, first Y, second X, second Y. Now, all I have to do now is, once I've gotten to this stage and set it all up, it's really just put the number instead of the letter. Now, I would suggest always putting a negative number in brackets, just so the calculator will help you out. Okay, so in essence, I'm putting in the x2 value, which I see there is 6, take away the x1 value, okay, which I see there is 1. Then the y2 value, now that's -1. I'm going to put it in brackets just because I said I would. It won't actually matter what's in the front but in terms of the calculator, but let's not be like idiotic in terms of giving different instructions all the time. So y2 take away y1, now that's a positive number, so it can go in without brackets. Now, if you did put in brackets, everything in the brackets, it wouldn't actually make a difference. It would just make programming the calculator harder. And this might be as easy to do by hand. 6 minus 1 is 5. Okay, so it'll be 5 squared plus, now -1, I forgot to put the square there. -1 minus 1 is -2 to be squared. Now I'm keeping the brackets there, and I didn't keep the brackets in front of the 5. A positive number squared will always be positive. But if I put -2 to be squared into the calculator, it will see that as -2 times -2, which is +4. Now, if I put -2 squared into the calculator, it thinks I'm saying minus times 2 times 2. Minus times 2 is -2. -2 times 2 is -4. So it can just be a small thing, and could be a reason why you're getting a persistent error, is just small little things like that hopefully that will help out if you do make that mistake. Now, if I do the square root of 5 squared is 25, and I could just put this whole thing in the calculator and be done with it, but my calculator is on a different screen. Plus 4 minus 2 to be squared is +4. That's the square root of 29. Now you just need to do the same thing for BC, and I have this done out nice and handy here. Okay, so that was what we got for the first one. The second one, same thing, write out the 2 points. I labeled them first x, first y, second x, second y. And it wouldn't matter if you swapped them around in the sense of if you called 8, 4, x1, y1, and then 6 minus 1, x2, y2. Okay, it'll get the same answer. I put them into the formula, put it to the calculator, and I got the square root of 29 again. So that's proof. Now I state it, okay, and I state it explicitly because sometimes they want that. Now sometimes they don't. So it's just that situation. Always put in units, okay. Even if you don't think they want it, always put them in. Always state your answer, and always in a way box it so that it stands out. Now that was a power 1. So remember, a power 1 and 2 are marked together. So without measuring the diagram, show that AB is perpendicular to BC. Now the second I see perpendicular, my brain goes straight away to slopes. Okay. So in a way, you should be expecting it. In the exam, they're going to assess slope, distance, potentially midpoint, equation of the line. It's just bog standard. Now where they do it, which question and how they approach it is irrelevant, really. If you think that's the strategy, do it. Okay, so the slope formula is rise over run, the difference in the y's divided by the difference in the x's. Okay. So if we find the slope of AB and the slope of BC, we can test if they're perpendicular to each other. And if they are, they're at 90 degrees. Okay. So I'll do quickly here for AB. So A is the point 1, 1. And B is the 0.6 on the x minus 1 on the y. So again, I can label them first x, first y, second x, second y, and then put them into the formula. So again, the minus number there, it can go in brackets. It doesn't actually need it there because it's the first of the list, but just to be consistent with what I said earlier, take away 1. I don't need that in brackets, although I could. It wouldn't make a difference if I did. Okay, just don't need it. And then on the bottom, the x2 value is 6, take away 1. I can do this in my head. -1 take away 1 is -2. Okay. On the bottom here, 6 take away 1 is 5. So -2 over 5. Now, a perpendicular slope, one of the simplest ways of finding out what it is to turn it upside down and change the sign. But there is another way where you can multiply the two slopes together, and if they give you an answer of -1, then they are perpendicular. So we need to know the slope of BC. Okay, so this line here. Now I've done it on the next page, just that's the first one we just did. This is the second one. So again, I've written out the slope formula, the 2 points. I've labeled them first x, first y, second x, second y. and then substitute the numbers in. So instead of the y2, I'm putting 4. Instead of the y1, I'm putting -1. Again, I'm putting that in brackets because the minus by a minus there will change to a plus. And if you are using the calculator to type this in, then that will make the calculator understand what you're saying. Okay. And then the x2 value is 8. So I substitute that in instead, take away the 6. And again, I don't need brackets because they're positive numbers. So I did it by hand. 4 take away -1 is the same thing as 4 plus 1, which is 5. And then 8 take away 6 is 2. So we know from just the previous page that if we turn the slope upside down, okay, and change the sign, that'll show us what the perpendicular slope is. But I've done it using the other method, which is kind of preferred from my experience of Mark and Junior Cert, which is a long time ago. I moved up to Leaving Cert. But the slope of AB times the slope of BC is equal to -1. So multiplying -2/5 by 5/2 and put that through the calculator, do we get -1? We do, therefore the perpendicular. I probably should have stated that actually. Therefore perpendicular. Now just say that and put that in brackets, whatever, or put that in a box. That's part 2. So remember, part 1 and 2 are marked together. In part 1, we had the distance formula. And then for part 2, we had the slope formula. Now, Kieran, this is part C. Actually, there's 2 parts to it, is there? Okay. Again, this is part 1 and 2 marked together. It's a 10C. So Kieran makes the following statement. Kieran's statement. Every parallelogram is a square. Okay. Now, if you know your definitions, like a square has sides of equal length and the angles opposite. So you can just even draw a square. That's a square. Okay. Now, a parallelogram might look something like this. I'm not doing a very good job, but maybe more classically like that. Okay. So the angles opposite are equal. Okay. Now the sides aren't of equal length. So the question then is asking, is Kieran's statement true or false? Justify your answer. So Kieran's statement, is it true or is it false? You have 50-50 chance of getting it right by guessing, but you need to have a reason behind it. Okay. So the reason I took from the marking scheme is a parallelogram is defined as a shape with parallel sides where the opposite angles are equal. Okay. So again, that's your parallelogram. Are the sides parallel? Yeah. Are the angles opposite each other equal? Yes. Okay. Now a square, okay, those sides are parallel, and opposite sides are equal. All sides are equal, or all angles are equal. They're all 90, but the opposite angles are equal. So yeah, it's true because it satisfies those requirements. Now the second part of part C is write down the converse, which in a sense is the opposite. Okay, what's the opposite of white? Is black. Okay, the converse of white is black. So that's actually a really easy statement. You just take the statement he had. Every parallelogram is a square. Well, the opposite statement there would be every square is a parallelogram. I don't know why I'm writing that because I want to spell it wrong. I did spell it wrong. Okay, only 1 hour. That's it. So it's actually a really easy question. Sometimes those things put me off because I go, it can't be that easy, but sometimes it can. And it's gotten increasingly more so like that. Some questions are very direct. Sometimes they give you the formula within the question, which is unusual for me from my maths education. But I come from a time when you were given no formulas and you were given marks for remembering the formula, which was in a way nice. So that's the end of question 7. As always, if you want a copy of the notes I'm working off, send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists, and see you on question 8.